In this video we will learn about variation of pressure in a fluid, and for that we have we are considering this is as a small element of a fluid with dimension delta z, delta y and delta x, with the axis taken as z in this direction, x and y in, we are taking our axis as like this. So for in order to find out the variation of pressure in this axis, so we are assuming that variation of the pressure in in z direction in z direction to be del p upon del z, and in y direction del p upon del y, and in x direction del p upon del x. This is variation of the pressure in x direction, in y direction and in z direction. And let's first suppose that at the center of this small elemental fluid volume, at the center the pressure is p. Okay, and the weight of this liquid, the weight of this elemental area be rho g delta x, delta y, delta z, that is rho g into volume, and rho g we are assuming as gamma. So this will be delta x, delta y and delta z. Okay, if we are assuming the pressure at the center to be p, and we are moving at the surface of this elemental fluid, so what we will get here pressure to be p, and we are moving upwards, so delta p by delta x will be positive. So plus delta p upon delta z into delta z by 2, we are multiplying by delta z by 2 because we have moved delta z by 2 2 unit distance upwards. This is the variation of pressure on this surface. And what is the what is the force what is the force here? It will be delta x into delta y. Similarly, if we talk about the downward surface, since in the downward surface the rate of change will be negative, so del p by del z will be negative. So here the pressure will be del p by del z into delta z divided by 2 into, this is the pressure in the downward surface. And if we talk about the force, then the force comes to be delta x into delta y, and this is minus because we are gone in the negative direction from the center point. Similarly, if we go in the positive x direction from this pressure, we will get here the pressure at this surface will be p plus del p divided by del x into delta x divided by 2 delta x divided by 2 into delta y delta z. And if we talk about this, we are getting in the negative x direction, so delta p del p divided by del z x will be negative. So p minus del p divided by del x into delta x divided by 2, this is the pressure at the surface. And delta, and if we talk about the force, then it will be delta multiplied by delta y into delta z. Okay, and if we talk about the force in the y direction, since we are going in the positive direction, so this will be positive. So p plus del p divided by del z into delta, sorry, there will be y delta y by 2. And if we talk about the force, this will be delta y, delta z into delta x. And similarly, at the backward surface, we are going from center to the backward surface, so we are moving in the negative y direction, so del p upon del y will be negative. So p minus del p upon del y into delta y by 2 into delta into del what we this is the pressure variation. And if we talk about the force, then the force will become to be delta z into delta x. Okay, now we know that the fluid is static. The fluid is static fluid is static, so all the forces will be sum up to 0. So we can write here sigma fx is equals to 0, sigma fy is equals to 0, and also sigma fz is equals to sigma fz is equals to 0. So if we sum up all the forces in x direction, so in x direction if we talk about, so sigma fx equals to 0. So if we solve it, p minus del p divided by del x, delta x divided by 2, delta x divided by 2 into delta y, delta z, it is acting towards positive x axis, so this will be positive, and this is and plus this minus p plus delta p, this is negative because this is acting in the negative direction. So and this is del x divided by 2, and this will be delta y delta z is equals to 0. And if we solve this, delta y delta z, delta y delta z will in common, and it is taken out, and this p and this p get cancelled out. We will remaining with delta p divided by delta x minus delta z by 2 is equals to 0. So this will be delta p, this will gives to delta p by delta x equals to 0. We have assumed that the rate of change of pressure in the x direction to be delta p by delta x, del p by del x, and which comes to be 0 here. So the variation of the pressure in the x direction will be 0 in the static fluid. Now we will talk about in y direction. In y direction, if we talk about in y direction, then all the forces will sum up to be 0. So p plus del p divided by del y delta y by 2 into delta z into delta x. This is the force, and this is the force that is in opposite on the opposite face. So minus p minus del p upon del y into delta y by 2 and delta z into delta x is equals to 0. Here will be delta x, sorry. So delta z and delta x will be taken out as common, and we are remaining with we are remaining with sorry, here will be positive and here will be negative, because this force is acting in the because this is acting in the negative direction of y, and this is acting in the positive direction of y. So we will get, if we solve this, we will get this p and this p will cancel out, and we are remaining with delta p upon delta y by 2 is equals to 0. This implies delta p upon delta y is equals to 0. So variation of the pressure in the y direction comes to be 0. That means in x direction and in y direction, what we have assumed that variation of the pressure, we have assumed that delta p by delta y sorry, not delta, del p by del y del p upon del x comes to be we have assumed this pressure, and this pressure comes to be 0. Now if we talk about in z direction, in z direction in z direction, so in direction we will get three forces, that is the pressure on the opposite walls, pressure force on the opposite walls, and the weight of the small elemental area. So if we take the small elemental area, then this will be p minus delta, sorry, p, this force is acting upwards, so this will be positive, so del p upon del z into delta z by 2 multiplied by del x del y, and this will be negative because this is acting downward. So p plus del p upon del z delta z by 2 into del x del y, and we are subtracting with 2, so we will get gamma into del x del y del z, which comes to be 0. And if we solve this further, we are getting this p and this p will cancel out, and delta x delta y will get common, and this will become 0. So we are left with delta del p upon del z del p upon del z delta z by 2 minus minus equals to gamma is equals to 0. So if we solve this, we will get, sorry, here sorry, here will be delta z and delta z also. So delta z will be common, so we will left with delta p by delta z is equals to minus gamma. So we are getting that in the if we move in the direction of z, then the variation of the pressure comes to be minus gamma, and this is nothing but the product of the density of the water and the universal gas constant. So by this we can say that if we, and the negative sign shows that if we move upward in the z direction, if we go upward in the z direction, the rate of the pressure will get decreased. So the rate of pressure variation in the z direction comes to be comes to be gamma, that is negative of gamma. So by this we can see that if we go downwards in the water, so pressure will be increases. So we have talked about x direction, y direction and z direction. In the x direction the pressure variation is 0 in static fluid. In the y direction too the pressure will be 0, but in when we move in the z direction, the rate of pressure variation uh, is it comes to be gamma. Okay, so this is all about pressure variation. Thank you.